Hello and welcome to the AHSS Guidelines blog. My name is Max Biegler, and today I'd like to talk to you about microalloying of gas metal arc welding wires to increase mechanical properties and corrosion resistance of welds. So let's jump right in and look at a little introduction. All welds, and especially gas metal arc welding, causes grain coarsening and brittle weld zone. Why is this a problem that is most visible with gas metal arc welding? Because we're introducing more heat compared to other welding processes. If you want to weld advanced high strength steels, a weld zone with a similar strength to the base material is desired. This problem gets even larger if you're welding a steel with a higher strength class, because then the difference between the steel substrate and the weld zone will get larger progressively with the strength of the steel. So the idea is to introduce some elements through the gas metal arc welding filler wire that you don't usually have in your substrate because either you don't want it there or it's too expensive to put it in the whole steel. And these elements are then supposed to create a finely grained microstructure with a higher ductility and overall also a better corrosion resistance. On the right, we have an example where we welded at the top with a conventional filler wire. This leads to relatively severe material loss in an accelerated 15-year corrosion test, and also a certain fatigue life here with a maximum of 4.8 lives, or 10 to the power of 5 cycles. We also have to descale the weld after welding because there's slag on it, which will further decrease the life expectancy of the weld. If you use a microalloyed wire, we don't get any corrosion in the 15 years corrosion test, and we get 2 times the fatigue life of the same with the same weld just by using a different wire. How does this work metallurgically? During cooling, the grain refining elements in our microalloyed wire will segregate at the phase boundaries and reduce the local phase transformation temperature. This will increase the formation of smaller retained austenite grains and in turn also suppress carbon reactions of the steel, so less cementite is formed. And this creates an overall finer microstructure which has better mechanical properties per definition. If you want to weld very high strength classes, such as 980 megapascals or more, some alloying concept, for instance, is using niobium and chromium microalloying. If we look at some industrial use cases, we have the wheel rim weld on the top, where in a conventional weld we get slag and pores in an X-ray test. And in the new microalloyed welding wire, we don't get any slag, so we can save on a descaling, on a cleaning process, and we also don't get any porosity or any cracks around the welded zone. A similar example is for an EV chassis frame on the bottom. The corrosion behavior was significantly improved in, again, the same 15-year accelerated corrosion test. And we also could leave out the acid descaling process, so saving us a whole process step that we would otherwise need to clean the welds. So in conclusion, gas metal arc welding wires are the key to welding of higher strength steels. If we have a microalloyed wire, we can cause a finer grain microstructure, and that eventually leads to a better mechanical and corrosion performance of the weld zone. In addition, by saving alloying elements, so if we use a microalloyed wire rather than an alloying concept that uses, for instance, nickel, we can also cut on the cost of the wire itself because we're using less alloying elements. So that's all for today. My name is Max Biegler. I'm the joining editor of the AHSS Guidelines. In case of any questions, please don't hesitate to get in touch and keep watching. We will put out a lot more content like this in the future.